right, guys, let's go ahead and do some of this review. Again, this first section is review from last week, but if we can't get this, we can't do this week. Kind of what I mentioned last week about this stuff. So end behavior. We need to understand end behavior. More importantly, what it really means. Not necessarily, if you're still confused on how to write it, that's okay. What I really want you to do is really understand what end behavior is. And like I said last week, is basically end behavior is what is my graph doing at the left end? Is it going up or down? What is it doing at the right end? Is it going up or down? Okay, so how do I find end behavior? Let's look at number one. You need two pieces of information for end behavior. The first piece is leading coefficient because it tells you about your right side. It tells you if your right side is going up or down. So at number one, the leading coefficient, because it's in factored form, is going to be in front. So if you look, all we care about leading coefficient is it positive or negative. So my leading coefficient is negative, which means that my right side is going down. Okay? So if your leading coefficient is positive, the opposite is true. Your right side would be going up. All right? So that's the first piece of information. The second piece of information is you need your degree. All right? When it's in factored form, you add the degrees of everything that has a factor of x. So if you look, we only have one factor. This is in factored form because of the parentheses. So this x factor has a degree of 2. There's no other factor, so that means my degree is 2. So how does that help us? Well, your degree, all we care about is odd or even. In this example, my degree is even, which means our left side does the same as our right side. So that's what the degree controls. Is it do the same or different than the right side? So since since my degree is even, my left side is going to do whatever my right side is going to do. Okay? They are the same. So in this case, we're going to have both left and right going down. And if I had to just really look at that, if I had to graph this based off the ends, my right side will be going down and my left side would be finishing down. So my graph would have the left and right end going down. Okay, how do I write that? Pretty simple. We always start with this template. This is what we worked on last week. And we got to fill in these blanks. And this is what your quiz was on last week. So we want to talk about the right side. So when we talk about the right side is always positive infinity because there's nothing stopping me on the right side. So my right side, we say, is positive infinity. It's going to positive infinity. So on the right side is my graph going up or down. So my graph is going down to negative infinity. Okay, now the left side, when we talk about the left side, it's negative infinity. The left side is our negative infinity side. So this is the left side now. And what is the graph doing on the left? It's going down as well to negative infinity. Okay, and that's end behavior. That's what we talked about last week. Again, yes, I do want you to be comfortable writing it in, but this section, this week, it's really important that we understand, can I understand what my graph is doing on the left and right based on the equation? Is it going up or down? Okay. All right, number two. If we're doing number two real quick. All right, so same idea. What's my leading coefficient? So this is in standard form. Notice this one had parentheses over here. This one does not. Standard form, our leading coefficient is the highest powered. What's the number in front? So it's negative. So leading coefficient is negative, which means my right side is going down. Okay. Now we look at the degree. Since this is in standard form, we do not add the exponents in standard form. We just look at the highest exponent, which is this guy. This is going to be odd. So my degree is odd, which means my left side does the opposite of my right side. So since my right side is going down, my left side does the opposite, goes up. So if I had to sketch this really quick, my right side goes down, but my left side goes up. Okay, and that's the important part this week because we're going to be graphing these things. How would I write it using function notation or end behavior notation? We do this again. The x's, we're going to fill in the blanks. All right, so I like to start with the right side. So this is going to represent my right side. So my right side, the right side is always the positive infinity side. So positive infinity is my right side. What does it do on my right side? It goes down. When it goes down, it's going down to negative infinity. Okay, left side, what represents my left side for these polynomial functions? It's negative infinity. And what is my graph doing on the left side? It's going up. And when we go up, it's going up to positive infinity. Okay? All right. Let's do number 5. Okay. Same idea here. Leading coefficient should be pretty easy to see. This is in standard form because we have it, in factored form because of the factors. So my leading coefficient here is positive. So I have a positive leading coefficient because it's 3, which means my right side is going up. Okay. My degree here. So now because it's in standard form, we want to add our exponents. So any factor that has an x in it, so 3 does not have an x, so we're not going to add its exponent. But this guy has an x and it has a power of 6, and this guy has an x and he actually has a power of 1. Even though it's not written in there, it's a power of 1. So if we add our exponents with the factors that have a variable x, is going to be 6 plus 1, which means our degree in this example is equal to 7. Okay, remember, you only add the exponents in factored form. You would not add the exponents here. You would not add the exponents in this one. You would add the exponents in this one, but there's only one. So again, factored form, you need to add the exponents of the factors that have an x in it. So we have a degree of 7, which means my degree is odd, which tells me my left side does the opposite of my right side. So that means my left side goes down. So it would look like this. My right side's going up, my left side's going down. Okay, how do I write that? Pretty simple. On my right side is positive infinity, and it is going up, which means it's going to positive infinity. My left side goes to negative infinity. Okay, is it going up or down on the left side? As you can see, it's going down. So that means it goes down to negative infinity. All right, cool. Let's jump over to 7. So what we're going to do here is we're going to give the end behavior, okay, and tell if it crosses or is in tangent for the zeros, okay? So if you watched the video already, you kind of have an idea of how this works. But before we get into it, just real quick steps on how to do this. So to figure out what our zeros are and the end behavior of the whole polynomial, you have to put it into factored form. If it's not in factored form, you cannot do this. Okay, so we got to put it into factored form. So if you look at number 7, it is already in factored form. Okay? So when we do factored form, we should remember that we can solve in factored form. Okay? So the next thing is solve for the zeros. Okay? And how do we do that? You remember we have to split this up and put each factor equal to 0. So we're going to go x minus 6 equal to 0. We're going to ignore the power for now. Okay, we'll get back to that in a little bit. Ignore the power for now. And this one's going to be x minus 3 equal to 0. Okay, so we're looking for our roots here, or our zeros, or our solutions. So we're going to add 6 to both sides. So one of our roots is positive 6. And another one of our roots, if we solve here, is positive 3. Okay, so once we have that, we know where our roots are, and we'll talk about that. So once we have our roots, we want to answer this simple question. When we graph this thing, do these roots, when we graph them, we have to graph these roots, but is our graph tangent or does it cross? Okay, so I like to call this, does it slash? So we're looking at how does it cross our root. And when I say it, I'm talking about the graph. And we'll get into more detail on this as we go further. Okay, so what we want to do is, this is where we look at our exponents for each root. So the root of 6 had the exponent of 7. The root of 3 had the exponent or degree of 4. So this is what you want to think, okay? If the exponent on each root is 1, so there's a couple of them we have to understand. So if our degree for each root is 1, okay, or in other words, odd. So think of 1, 3, 5, 7, and so on. Okay, what does that mean? So what this means is we are going to have a crossing root or a crossing graph. Okay, and what does that look like? So when we graph this thing, if it has a power of 1, 3, 5, or 7, so if you look, if the root, if my factor had an odd, okay, that means it's going to cross at that root. Okay, so if we have x equal to 6, which let's say it's here, and then we have x equal to 3, which is here. All right, and I got that from these answers. If it's odd, that means when I do my graph at x equal to 6, since it's odd, my graph is going to cross this point. It's actually going to cross over this point. It could cross that way or cross that way. Okay? As the power gets higher, and this is something we're going to talk about, as the power gets higher, it crosses slightly different. For example, if it's a power of 1, it crosses like a line, like a straight line. It slashes. A power of 3 will kind of saddle. Okay? And as you get higher and higher the power, when it crosses, these saddles change slightly. Okay? But it's pretty much, we're going to cross our graph. at 6, because it's odd, our graph crosses here. And that's kind of what you just have to remember. We're going to cross here when we graph. Now, the even degree, okay, so we'll put this over here. When we have an even degree, so when our degree is even, for each root, so that means 2, 4, 6, 8, and so on, I have what we call is a bounce. All right, so that means we are going to have a tangent or a bounce. That means our graph is not going to cross that root. So if you look, we have an even degree for the root of 3, was an even degree. So that means we are going to bounce off that degree. So it's going to be called a tangent. A tangent means it just touches the root. It doesn't cross it. So if I was graphing, it would touch and bounce off. If you came from the bottom, it would touch and bounce off. Okay? So in essence, you have to know two types. If it's an odd root, so our power is odd, okay, that means we're going to cross our root. It's actually going to cross over. Okay, we'll get into more details as we get into next section. All right. If it's an even degree like this one, that means our root has a bounce to it. We'll touch the root, but we won't cross over the x-axis. Okay, so odd crosses over the x-axis, evens bounce. They never cross the x-axis. Okay. All right. So those are pretty much the rules. Okay. So if we were doing number 8, so I want to do number 8 for you, but I'm going to move the rules so I can have some room to work. Okay, we'll put the rules off to the side. Okay, so number 8, in order to do this, I first want to put it in function form. Okay, I'm sorry, factor form. So I want to factor, and if you notice, I can factor out a -2 and an x for GCF. So we would do GCF factoring here. Again, that's why I told you factoring is very important. It doesn't go away. So -2 is my number GCF, because they both can be divided by -2. And then my variable, since they both have a common variable, I picked the lower one, which is just going to be x. Since this is GCF, I'm dividing out. Okay, so we want to turn it into factored form, so now we have this. We have 2x to the second minus 1. Okay, and then we have our GCF -2x in front. Sorry guys, I made a mistake here. This should be x squared minus 1. Okay, so let me just make sure we're comfortable with that. So -2 divided by -2, that's +1. I'm not going to write it because I still have an x squared minus 1. Okay, so we got a factor completely. So we did GCF, but if you look, this is quadratic pattern, the A, B, C. Because I have a power of 2, this is where these guys come into play. All right, those methods. So we got to be good with this. So my A value is 1. My B value is not there, but my C value is here. Okay, so I'm going to rewrite this just to factor. This is going to be x squared. Since my B value is gone, we put a 0x for my B value, and my C value is there. So again, A, my B, and my C. Okay? Because my A value is 1 here, that means we're going to use X method. Okay, so let's use X method to factor. A times C is -1. My B value is 0. What multiplies to -1? That adds up to 0. That's easy. -1, +1. That's my magic pair, so we put this in factored form. Okay, so that's going to be X minus 1, X plus 1, and then don't forget your GCF you had before. All right, so we have factored completely. It's completely factored. The next step says we want to solve for the zeros or solve for X. So we're going to split this up. Any factor, put it equal to 0. Split this up so we can solve for X. So we have -2x equal to 0. X minus 1 equal to 0. X plus 1 equal to 0. And if we solve, we're going to do this a little quicker. If I solved here, X is equal to 0. Okay, we divide by -2. X equals to 0. This one we're going to add 1. X is equal to 1. Here we're going to subtract 1. X is equal to -1. Okay, so remember, we're eventually going to graph these. So if I was graphing these, we would just put them on the x-axis. So X equal to 0 would go there. X equal to 1 would go there. We'll just pretend that's 1. And X equal to -1 would go here. So it's a real quick sketch, but this is eventually what we're going to be doing. Okay, so those are my roots. Now we got to ask, how do they cross? Do they bounce? Or do they actually cross through them? Okay, so I'm just going to write above each point what actually happens. And then next time we meet, I'm going to show you how to actually graph them. So this is how it works. So X equals 0 came from this factor. Okay, so my X equals 0 root came here. We want to look at the power of this X factor. What's the power of this X factor? And you'll notice it's a power of 1. Since it's an odd power, that means odd powers cross. So at 0, X equals 0, I would cross. So this is getting crossed. So we're going to actually cross over the x-axis. Either if I'm coming this way or I'm coming this way. We're going to cross it with kind of a line, or depending on what we have, a saddle. Okay, we'll talk about that more specifically later. So since it's odd, since it's 1, this factor has a power of 1, and that's how we got X equals 0. We're crossing at 0. Okay, now X minus 1, or X equal to 1, came from the factor X minus 1. What's the power of that guy? If you look, he's also a 1, which means X equals to 1, we are going to cross. So we have a cross here. We're crossing. We are crossing over here. So X equal to 1 is another cross. Okay, and then last but not least, X minus 1 came from this factor. What's the power of that factor? It's 1, which means this one is going to get crossed as well. We're going to cross through him on the graph. So this one gets a cross. Okay, so that's kind of what you wanted to do for 7, 8, and 9. We're just labeling them. Does my zeros get crossed? That means they have an odd degree for each factor. You look at the factors individually. It's an odd degree. If it's an even degree for the factors individually, that's when we have a bounce, or what we call a tangent. Okay, so does it cross or is it tangent? So just to be clear, crosses are odd degrees, tangents are even degrees when we look at the individual factor. So you must factor before you can even answer these questions. Okay, hopefully that gets you through 1 through 9. Let me get you the checking code and get you out of here. Okay, stay on if you need further explanation. I know this is kind of a weird thing, but it's something we got to get comfortable with. Okay, because we're eventually gonna turn our equations into things that look like number 6. All right, they start getting a little funky, and it's just a different way of graphing. All right. Let me get that check-in code for you.